Okay, so this is going to be homework problem number 17. So let's do the same thing. We're going to start out by listing the vectors. Looks like we have point A. Point B, point C, and point D. Point A is going to be 0x, 5.6y, and 0z. Point B looks like it's going to be negative 4.2x, 0y, 0z. Point C is going to be 2.4x, 0y, and 4.2z. And then point D is going to be 0x, 0y, and negative 3.3z. Now what we can do is we can make the cables. So we can make the vectors. We're gonna have vector AB, AC, AD. This one's going to be negative 4.2, 5.6, 0. AC is going to be 2.4, 5.6, 4.2. AD is going to be 0, 5.6, and then negative 3.3. Okay. And now we make the lambdas of each of these. We have lambda AB, lambda AC, lambda AD. It's going to be a very long straight line, square root, very long straight line, square root. Very tedious. Extremely, extremely tedious. 0, 5.6. Actually, they're all going to be 5.6 here. Only J value is the only Y value in the whole thing, so we just throw 5.6 down everything right here. And this could just be minus 8.3, maybe plus, they're gonna be plus. This one's gonna be 2.4, well, nope, oops, wrong place, 0 here, 2.4, and what's that, 4.2, all positive. Be 5.6. This one's gonna be 2.4, negative 4.2, 4.2, plus here, and then it's gonna be plus. I think this one's a 0. Gonna give us 1 I hat, J hat, and a K hat. And I'm willing to bet they're all going to be fractions, but I might have written these as decimals. Yeah, it looks like I wrote these as decimals. So, looks like we have negative 0.6. We have 0.8 and 0. J hat. Then here we're going to have 0.324 plus 756. 0.756. And then this is going to be J hat plus 0.567. Here we're going to have 0. I hat, by the way. 0.861 minus 0.507. So there, now we have lambda for all the vectors. Same thing with the last problem. Tension in AB, tension in AC, tension in AD equals tension AB, tension AC, tension AD, lambda AB, lambda AC, and lambda AD. Okay, all this would equal to is all the vectors we just had here with a variable t in the front. So to write all that out, t a b t a c t a d. This would be negative 0.6 I hat plus 0.8 j hat plus 0 k hat. This would be 0.324 I hat plus 0.756 j hat plus 0.567 k hat. And then this would be 0 I hat plus. I don't think I even denoted if that was plus or minus. It is. Plus 0.861 j hat minus 0.507 k hat. That's what that would look like. Aha. I forgot. Tension AD. We're given it right up here. Tension AD is 531. So what we could do is 531 here. And 531 times 0 is going to be 0 I hat. Let's do 531 times 0.861. We're getting plus 326. 83 j hat. Whoops. My calculator did not type in the 861. 457. 0.48 j hat is going to be minus 531 times 0.507. We're getting a negative 269.53. Wonderful, splendid. And now we move on to equilibrium. Sum of the forces in the x direction. Sum of the forces in the y direction. Sum of the forces in the z direction. Okay. 4. Tension AB. Tension AC. And 4. What variable are we trying to find? Is it P? Force P going upward. Vertical force of the balloon at A. There's a vertical force P. So we can just say this one is E. We're going to have negative 0.6, 0.8, and then we're going to have 0. TAC. 3, 2, 4. I think it's 4, yeah. Plus well, I guess I'll only say plus if it's Unless if it's negative, I'll denote it. It's gonna be what, 0.756? And then 0.567. And then point P, it's got no X, it's got one Y, and it's got no Z. But we ain't done yet, because the sum of the forces in the Y direction, we've got this for Y, this for X, and this for Z. And we're gonna have to flip whatever signs these are, because to set them equal to 0, they will be on the left side of the equation, and we have to put them on the right side of the equation. So for this vector here, which is our x, y, and z vector, we're going to have to plug in 0, negative 457.48, and then we're going to have to do a positive 269.53. And what this is going to give us, if we do the inverse, is the variables in our vector left to right go top to bottom. So if it's TAB, TAC, and P, left to right, top to bottom, it would be TAB, TAC, and P. Okay, let's plug these in. Negative 0.6, 0.324, 0, 0.8, 0.756, 1, 0, 0.567, 0, vector 1 done, vector 2, 0, negative 457.48. We have a positive 269.53. And when we take vector A and give it the inverse, multiplied by B, so inverse square, inverse vector A times B, we are getting 256, 475, and negative 1022. My goodness, did we forget to make J vector negative? I'll have to go to my teacher and see this, because I believe, I really do, that the P vector that's doing this, that's rising up through the sky, is positive. So with just common sense, that's going to be a positive 1022. I believe that J hat is negated. But yeah, that'll be clarified in my teacher's office hours. You guys should just take my word and look this up. Do your own research. Goodness me, I gave you the answer. What more do you want? You didn't come here for the understanding. You came here for the answer. I know what I'm peddling. All right, so that problem's done.